Well, good afternoon, and welcome to this session on becoming an insights-driven enterprise. So, at the end of this session, I want you all to be concentrated on being insights-driven, okay? Good. So our first speaker in this session is Sudha Viswanathan, who is a staff software engineer with Wayfair. And I was just saying to her that Wayfair does have an office here in Boston, just basically down the street, but she's not in the Boston office. She flew here to speak. And following Sudha will be Kathy Schneider, who's the Chief Marketing Officer for KX. So let me turn this over to Sudha.
Yeah, thank you. Hello everyone, welcome. I am Sudha, and as she said, I'm from Wayfair, and I lead a few initiatives in storefront data engineering team. I'm your humble narrator for today's talk, and in today's talk, I'm going to present the Clickstream data platform that we built at Wayfair over the years, and I'm also going to show you how we enable high-quality data analytics to our stakeholders. So, how many of you are Wayfair customers here? Awesome. That's almost like more than like 60% or so. That's nice. So Wayfair, as you might know, we are the largest destination for home furniture. We are operating completely online, and we are also venturing into physical stores in the near future. And the cool thing that I like about Wayfair is big stuff ships for free, be it big appliances like refrigerator or your backyard furniture, everything shipping is free. And so Wayfair has one of the largest and deepest collection of items for every space, style, and budget. So it basically enables everyone and gives them the power to create a space that is just right for them. So today we are operating, we have our offices and warehouses throughout US and also some other countries like Ireland, UK, and apart from Wayfair.com, we also own Johnson Main, All Modern, Bridge Lane, and Perigold. So moving on. Today I want to introduce you to Clickstream data. I want to tell you what's the importance of Clickstream data, and I want to show you the data processing architecture, and I want to talk about some of the core business critical processing that we are handling as a part of this platform, and I also want to share the data modeling technique that worked for us, and would like to show you how we enable data analytics and reporting to our stakeholders. And last but not the least, I want to wrap up my talk by, by talking about how the data processing has evolved over the recent years with the advent of cloud computing. So Clickstream data. So when you log into Wayfair.com or when you use our mobile app, everything that you see and everything that you do, all the actions that you perform, everything is being tracked, and this data is called as the Clickstream data. So when you actually browse for some products, and then when you click on a product to take a deeper look, what is the product that you're adding to the cart, what filters are you applying, how did you come to Wayfair.com? Did you just type Wayfair.com and come, or were you redirected to our website from some third-party advertisements like Facebook or Google? So all this, all this data is what we call as Clickstream data, and this is very important for us to make a lot of business-critical decisions. Wayfair being a data-driven company, we use data heavily, and we rely upon data to make critical decisions every day or even every minute. So some applications of this Clickstream data, one, it helps us to understand the efficiency of different marketing channels which drove traffic to Wayfair.com. And then it also helps us to understand how a site is performing. Especially when the performance is not good, it helps us to understand, is it because of some inefficiency in the advertising spend? Are we not driving traffic to the website? Or is the website not behaving as intended? Maybe the site itself is slow, or something is broken, which is kind of impacting our conversion rate. So Clickstream data actually helps us reveal some of the issues that might lead to customer churn. And it also helps us to understand the efficiency of A/B testing. And the last one, ad bidding, is my favorite use case, and I'm going to dwell deeper into it, and I'm going to show you how Clickstream data is actually helping us to make data-driven decisions. Let's say you want to purchase a sofa for your house, a red sofa. So you go to Google, and then you search for red sofa. So at the back end, the Google algorithm runs, and they display a lot of ads from different shops. So the logic behind the algorithm is there are two things that it considers. One, the relevance of that product in their shop. Two, the bid price offered by the shop to Google. Let's say Wayfair gave the biggest bid, it won the bid, but still, if it doesn't have red sofa for some reason, we wouldn't see that in the list of advertisements. So these two factors impact the ad placements. And let's say we are seeing these ads, Wayfair, Home Depot, all modern article, and then when you see a lot of ads, you eventually click on one of them. Let's say you click on Wayfair.com and Wayfair ad, and then it takes you to Wayfair.com where you see all the other specifications about this product, the color, the cost, and lot other details. And all this information is being captured, and this is a part of our Clickstream data. So this data is fed to our attribution system along with several other data. So attribution is nothing but we want to attribute the revenue to different marketing channels. So we have a machine learning model which kind of uses all this data, and along with that it also considers several other factors like what is the type of that customer. Is he coming to Wayfair for the first time, or is he a repeat customer, or is he a customer who's just browsing without really doing any purchase? Where is he from? What are the past history? What are the orders he has placed? So it kind of considers all these, and then this model tries to incrementally understand effect of various marketing channels that led to the purchase of the product. So it kind of helps us understand the efficiency of our marketing spend, and thereby we are able to decide how much we want to bid for an ad across different marketing channels. So this is a good example of how we use Clickstream data and how Wayfair takes decision based out of that data. Moving on to the data processing architecture. So our processing is powered by BigQuery, which is a Google Cloud offering. So anyone familiar with BigQuery, used BigQuery here? Cool. So BigQuery is nothing but a serverless data warehouse, and it is built to process and transform petabyte scale workloads. So as I said, when you log into the website, all that you're seeing and all that you're doing is being tracked in the form of events data, and that is being ingested by Wayfair-wide. We have a real-time ingestion platform which is powered by Kafka and Google BigQuery, and all those events land into the staging area in Google. That is also in Google BigQuery. So we are also ingesting data from other teams and also from other OLTP databases like products, orders, and customer information. All this is ingested, and everything is stored in the staging tables in BigQuery. And the next stage is consuming that data, processing that, and transforming that. So we have two types of processing. One is the nightly batch. The other one is an intraday batch. So the nightly batch. Okay, so this is a nightly batch and the intraday batch. So nightly batch is basically consuming last 3 days worth of data, last 3 days because we want to account for late arriving events. And intraday is basically run multiple times during the day. It just processes the last few hours worth of data. So the combination of these two, right, a nightly batch and the intraday batch, we kind of combine these two data sets and we create this curated view, which is nothing but a combination of the data set processed by the nightly batch and the data set that is processed by the intraday batch. And this curated view is going to contain all the data, all the latest information, and it is kind of acting as a single source of truth so that anybody can come and query and get the latest information out of these curated views. The next step is to use the data from these curated views, join with other curated views, and also from some of the foundational tables, which was the result of the previous processing step. We kind of join them and we create a nicely denormalized, flattened tables where we do all the aggregations, derive some important KPIs that is being used by reporting tools. So this curated tables is, as I mentioned, is kind of highly denormalized, and we are using Google BigQuery support for nested and repeated fields. I'm going to talk about it in the coming slides. So that is actually enabling us to get very good read performance. And in the consumption stage, these curated tables are being the source for a lot of our reporting tools. Looker is our main reporting tool. It's very powerful and very popular in Wayfair. And we also use other tools like Data Studio, Google Sheets, and we also expose this data through external API. And as always, this data is being consumed by product managers, business analysts, data engineers, executives, and so on. Moving on, I want to talk about some of the core processing, business critical processing that we are handling as a part of this data platform. The one core processing is visit definition. So visit definition is nothing but we want to split the customer journey and group the sequence of events into logical groups called sessions. So to give you an example, let's say I'm logging into Wayfair.com and I'm browsing at 12 o'clock. And then for a few minutes I'm browsing, and then I'm getting a call, and then I'm having my lunch, I take a nap, and then I come back at 4 o'clock to complete my purchase. So what we do is we kind of terminate the session that started at 12 because there was a lot of time where the customer was inactive. There's a lag period or a timeout period. So we terminate that session, and once the customer is coming back again at 4 o'clock, and when you are getting new events from the customer, we start a new session. So this is just one example of how we kind of try to split that customer journey and try to group the sequence of events into logical sessions. There are multiple other conditions as well where we are applying this logic. So we are doing this so that we get better insight into the customer journey, which is actually very important for us to answer, for many other use cases. Understanding customer journey is very important, be it gauging the effectiveness of A/B testing or understanding the impact of an ad that we place. Customer journey, knowing that is very important. Then the other logic that we are handling as a part of this platform is bot and employee data removal. Bot traffic, are you aware of bot traffic? Have you heard about it? Cool. So it's nothing but non-human traffic. Any traffic that we get from some automated process instead of from the real customer is called as bot traffic. It could be from our own tools that is kind of inspecting the health of a website, or it could be from the search engines that is crawling our site for their algorithm, or it could be from our competitors who are trying to scrap our pricing information, product information. So there could be various reasons where we get this broad traffic, and we cannot afford to include this traffic into our reports, because if you're going to include it, it's going to throw away our metrics. It's going to affect all the metrics. So it's important that we identify these bot traffic and we kind of remove it, and maybe in some form of an exclusion table, and then store it for later analysis. The same holds good for employee data also. The employee data is nothing but the traffic that is generated within Wayfair by some internal tools, admin tools. So we just want to remove that as well, because that is not that doesn't represent our real customer base, and we want to exclude that data. And the other thing is the experimentation advertising. These are two very critical use cases that we are supporting today. And in both the use cases, what we are trying to do is we are trying to stitch the session information that we kind of, I'm sorry. The session information that we got here, we're trying to stitch the user session information to the raw experimentation and advertising data, so that we're able to understand the customer journey, and we're able to answer a lot of analytical questions around the effectiveness of A/B testing and as well as advertising. And then moving on, customer device and mapping. So this is nothing but what we're trying to do here is we're trying to club all the cookies that belong to a customer, and we are trying to consolidate it and merge it into one identification cookie and map it to the customer. So we're doing this because sometimes for the same customer, for various reasons, the cookie changes. And when the cookie changes, we don't want to treat that customer as a different customer, because he is an existing customer. It's just that his cookie has changed. So we need some logic to basically, relate us all the cookies and map it to the same customer, so that we don't treat him like a new customer. So for an example, let's say I'm an existing customer of Wayfair. I've done a lot of purchases, and for some reason I want to reinstall my app. When I reinstall my app, that is going to generate a new cookie for me. So when Wayfair gets a new cookie, then they might assume that I'm a new customer. So that's why this processing logic is important, where we are able to relate the new cookie with the old cookie, because both are coming from the same device, and we are able to merge that and map it to the same customer. That way Wayfair doesn't double count its customer base and doesn't treat the existing customers as a new customer. Moving on. Okay, so as I told you earlier, our curator tables are denormalized, and we are heavily using the nested and repeated support offered by BigQuery, and I want to give you an idea and expose you to this idea of using nested and repeated fields, so that when you're modeling your data tomorrow, you will be motivated to use this. Yeah. So let's consider, some kind of orders data. As you can see here, we have order ID and we have some customer information. We also have some product information. So generally, we get this data in the form of a semi-structured events data, mostly in the JSON format, right? And in the traditional relational databases or transaction databases, the way we represent this data is we generally used to store all the customer information in customer dimension, all the product information in product dimension, and all other metrics along with the the keys, corresponding foreign keys. Everything will get into the transaction table. So this is like the typical star schema. I think most of you would have been aware of this. This is like normalized relational database, and this is very good for writes. Writes are going to be very fast with this, but when it comes to read, you will have to join all these tables in order to answer your analytical queries. So joins are expensive. So this is not suitable for our analytical workloads. So that kind of made us to evolve and start using the denormalized fact table, which is nothing but because joins are expensive here, we want to avoid that. So we are trying to pre-join everything, and then the pre-join result set is being stored in the form of one single fat denormalized table, so that you don't have to join anything for answering your analytical queries. Every question can be answered out of just this one table. So the joins are avoided, but the downside of this is, as you can see, there's a lot of data repetition, there's a lot of duplication. So for example, for this first order, because you have 3 products, the same customer information is being repeated 3 times. Now imagine this order has 100 items. So you're going to repeat the customer information 100 times. Now imagine how big this table is and how many orders are there, how many products are there. So imagine the amount of data duplication that is going to happen in this denormalized fact table. So it's going to cost you storage space, and it is also going to affect your query, because your queries are going to scan a lot more data than it is required. So we have, these are the traditional models, right? Now, I'm going to introduce you to another model that is, that is designed using the nested and repeated fields. So if you see here, this actually gets the best of both worlds. If you see here in this table, you have the customer information, order information, product information. So all the information is there in one table, so you don't have to join. So it is denormalized. At the same time, there is no repetition. Right, if you see here, the customer information is only once, although you have multiple products, we are not actually repeating the information. So it kind of gets the best of both the denormalized as well as the normalized. Like in normalized data, there is no data repetition. Like in denormalized world, everything is there in one table, so you don't have to join, and this also gives you very good query performance. So I'll just give you a brief intro into what is nested and repeated fields. So here, this customer data, right, ID, name and location, which is one logical unit, kind of forms one dimension table, is known as the nested attribute. So you can think of nested attributes as a set of attributes that logically represent a single dimension. Similarly, in the case of this product, all this SKU, description, quantity, price, all these are logically related to product. It kind of represents a kind of a dimension, and this is another nested field. But because one order ID can have multiple products, this nested attribute is also repeated several times for one order. So this is called as a nested and repeated attribute. So if you're interested to learn about this nested and repeated attribute, there are a lot of resources out there, so you can easily learn it. But my goal here is to expose you to the idea that this is a one-to-many relationship, right? One order can have different products, but in this case, where you have relationships like one-to-many, it is possible to represent that data in a single table without actually duplicating the data in order to get everything in the same grind, and thereby we can achieve good query performance. So yeah, that's about nested and repeated fields. Now let me dive into data analytics and reporting. So we are using many tools, as I told you before. Looker is the most powerful and the popular one. It seamlessly integrates with our BigQuery, not just with BigQuery, but it also integrates very well with other relational and article databases. And the cool thing about Looker is you just have to define your model. Your model is nothing but it's an abstraction layer between your users who are actually using the web UI, your analysts, and your database. The model, actually you define all the connection information, what tables you want to extract from the database, how the join kind of works. So once you define your model file, then you don't have to do any other coding. You can just expose your web UI to your stakeholders. Your stakeholders can come just pull whatever attributes they want, metrics they want, and they don't have to type any SQL. So the Looker at the back end, it is going to create the SQL for you. It is going to connect to the database, and it's going to bring the data for the stakeholders, and they can play around with it. So we are basically offering them self-service here. We are not really building any reports for our stakeholders. We are just building the Looker model, and we are giving it to them. So this is really convenient because we don't have to design and customize all their reports. We're just giving them, and they can play around with it. And the other cool feature about Looker is, I just spoke about the nested and repeated fields, and that works very well with Looker. It's you can easily unnest those nested and repeated fields within the Looker model. The Looker is actually directly connecting to your database. So you're going to get the most up-to-date, fresh data, and it also gives a very good drill-down ability. I had a demo to show the drill-down ability, but then due to lack of time, I took it off. But again, there are a lot of resources out there if you want to learn about Looker more. But I just want to give you an idea of, that there is a BI tool which kind of integrates really very well with BigQuery, and it kind of scales very well for us. The other interesting thing about Looker is the hub and spoke model. So this is nothing but, if you are coming from this object-oriented, how many of you are familiar with Java, any kind of object-oriented programming? Yeah, so you should be familiar with inheritance, right? So you have a parent class and you have a child class. The child class basically inherits all the behaviors of the parent class, but it will also have some features that is unique for the child class. The hub and spoke is just that. So your hub is going to have all the data sets that's kind of used across team. It is kind of centralized, single source of truth, and your spoke is kind of going to inherit that model, and it is kind of tailored for specific use cases. So it also has the ability to connect to other data sources, ingest, and connect to the existing model. So it's basically your parent-child relationship. That's your hub and spoke. The advantage of this model is one, code transferability. So today, if I want to develop a Looker model for a specific use case, I can just import the hub, and I can iterate, and I can start working to suit my specific use case. So it kind of gives me a jump start, easy start, because I'm able to transfer all the code from the hub. And the other thing is, if I want to make any change, I just have to make it in the hub model, and it's going to get reflected in all the spoke. So it kind of, helps us to have the data consistency as well. Moving on, I just want to wrap up my talk by talking a little bit about how this data processing has evolved. So when I was actually preparing for this presentation, I kind of remembered, just a couple of years back, there were a lot of pain points when I was using the open source Spark and Hive in the Hadoop platform on-premise. There were a lot of pain points, and even migrating everything to cloud was definitely a challenge. But now that we have all moved to cloud, and most of us are in cloud, just wanted to think about how those pain points have very beautifully addressed with the advent of cloud technology. So one thing is, how many of you have worked with Spark here? Okay, cool. So I think you will be able to relate to what I'm saying. So Spark is not ACID compliant for all the features and beautiful things that it offers. It's not ACID compliant, which means that when I'm doing an insert overwrite on a Hive partition, if for some reason my job fails, I'm going to lose the data. Right? It's going to corrupt my partition, and I'm going to lose the data. So unless I have a mechanism to read in the job, if I have that data in the source, or I have some backup, I'm doomed. I'm going to lose my production data. So that pain point is solved in BigQuery. And the other cool thing is rollbacks, right? So there have been issues in the past during the deployments, and It has corrupted our data, and I have personally spent sleepless nights to just recover a production table to how it was like 40 hours back. So when I learned about this rollback feature, this time travel feature in BigQuery, I was like, wow, because it's like, it means that even if you accidentally drop a table or if you end up corrupting the data, you can actually retrieve your data to a point where it was, as long as it is within that window of time. It's usually 7 days. So this is like such a boon to all the engineers, not only to recover, but even to debug some production issues. This comes in very handy. The other thing is DML operations. So a couple of years back when the CCPA was introduced, we were all in a fix because all our data was residing in Hive, and there's no way to delete it, right? Because deletes are not efficient. It's not even possible in Hive. So you really have to do an insert override even if a bunch of records are modified. And with BigQuery supporting DML operations, that pain point is also gone. And we just saw how nested and repeated attributes are helping us to design a table which is not, which is kind of giving us the best of both normalized and denormalized. Because a couple of years back, I was actually designing big, fat, single table which is going to hold all the transaction records, and it's going to take time to write everything, read everything, and again, that pain point is also addressed beautifully by BigQuery support for nested and repeated fields. This is kind of very specific for Spark, right? Whenever we want to deploy the Spark job, it's very important for us to understand you have to understand your infrastructure, the resource available, what jobs are going to run while you're running your job, what is your data volume, how the data changes during the processing. So you'll have to consider all this and then come up with a configuration like how many executors, what is going to be the memory, how many cores, and then you deploy your job only to see that a few weeks down the lane, the configuration that you have defined is not perfect and requires a revision. And BigQuery being serverless, again, that pain point is gone. And then integration with BI tools. We just saw how Looker is so efficient and scalable and flexible. A couple of years back, I was trying to integrate Hive tables with Tableau, and all I was trying to do was join two Hive tables in Tableau, and it was not working. And I had to go back and I had to join them and create a materialized table and then expose that pre-joined table to Tableau. I don't know, maybe things are different now, but my point is the BA integration was not that efficient a few years back, but now things have really evolved with technology, and that is also working seamlessly well. The other thing is simultaneous read and write. So I used to literally ask my stakeholders not to use a production table when the write is happening. Because simultaneous reads and write are not possible, so they have to wait until our jobs are done before they can actually run their queries or reports. Now with BigQuery snapshot isolation, there's no such downtime. Reads and write can happen simultaneously, which is again another nice thing. So yeah, that's pretty much it, and I want you to remember these few points out of this talk. So these are some of the things that made me like, wow, when I joined Wayfair and when I got exposed to this platform, these are some of the things that made me, this is really cool, and I really want you to take away those points. So one, there is a better way to model your data, and beyond your traditional fully normalized or denormalized, there is a better way to do it. Number two, as I just said, visualization, integration with BI tools has improved a lot over years, and a lot of our pain points are gone. And the third one is, as I just spoke a lot about how the data processing has evolved, the data processing with the advent of cloud technology is a big game changer for data engineers. So if you are one of them who are still using the Hadoop platform or the open source technologies, this is something that you need to consider about moving to cloud. Yeah, that's my talk, and questions please. I think we have like a couple of minutes. Maybe we will take the questions at the end.
Maybe a minute and a half.
Yeah, thank you. Yep. Thank you.
So how about the performance of the BigQuery, the big table?
The performance is really great, but the performance actually depends on a few things. You'll have to partition your data properly. Like in high tables, you have to define proper partitions so that when you're querying, a query just hits that one partition and gives the results soon. But if you're not going to properly partition the data, if you're just going to store all data in a table, then your query is going to scan everything, and that's going to take time. So the secret of performance as far as BigQuery is concerned is your partitioning and clustering. You can actually learn about it, like how you're storing your data. That is important, and that helps us to achieve the right performance. Yeah. There's one more question. Do you want me to take that, or?
Mike, you want to come switch slides, and we'll do one question while we're switching slides. Yeah, go ahead.
Yeah, please go ahead. What are the implements for collecting the events data?
Like, what is the instrumentation tool that you are using on the website and the app itself to collect the clickstream data, like key or segment?
Yeah, I'm not sure. It's just from, we're getting the events from Kafka, and we're just processing that in BigQuery. So yeah, that's the front-end tools. I'm not very sure about that. Yeah. Yeah, thank you very much.
Okay, thanks so much, Sudha. And we now have Kathy Schneider. Are you doing this or are you doing that?
I can use this one.
Okay.
It's easier.
There you go.
Yeah, that's fine, great. And did you find this one was working? Yeah. Okay, cool. That's excellent. Great. I will tilt it a little bit, so I'll stand right behind you. Hey, everyone. Thanks so much for joining us. My name is Kathy Schneider, and I'm Chief Marketing Officer at KX. And I just have a few questions for the audience, just so I can get settled in of what we have here. So how many of you are using real-time data analytics currently? Not as many. So those of you that are not raising your hand, I'm just going to assume you're mostly using batch historic data. I see a lot of, okay, great. Well, great, because that was the orientation of the session here that we have is, my goal really isn't to show you necessarily how to use it or how our technology works, but I'd like to really make a case for real-time data analytics and get you all excited to learn more. If that is about KX, super great, I'm even more pleased. But I think what's really important is that you take away how important this is for your businesses, and that you guys leaving here can actually make a big change and impact, maybe get a bit of spotlight for yourselves, because it's a really big area. We're calling it the new data frontier. And I'm just going to start here, and apologies if my voice from moving around goes light. I'll try to stay in the range here. So what we've seen, I'm going to share with you some of the trends that we're seeing. Now, KX does specialize in time series, real-time streaming analytics, okay, in order to drive decisions. And we operate in the world of both because the technology does also have a database and the ability to store and analyze historic data. But the real value that we're seeing is in this new frontier, which is right at the edge, using real-time streaming analytics and actioning it in decisions. And so I just want to share with you some key themes. So first around is technology continues to enable big ideas. And what we see there is really technology driving innovation. So for example, whether it's your industry, you look around you, I'm sure you can see this. I can't think of an industry where we're not seeing this, to be honest, but maybe you can bring some examples at the networking. That technology is really the driver of complete disruption. And if you kind of look under the covers of technology, it's actually software. So you see software-driven technology disruption. So think Uber, Airbnb, Netflix, even Amazon in the day. So that's a really big trend. And interestingly, the area of the large banks where there's a lot of regulation, where they were moving more slowly because of all that regulation, we're now seeing, I have some headlines here, some really big moves driven by technology. So for example, Google striking $1 billion cloud deal with the exchange, the CME group. Even if you don't work in these industries of the financial sector, this is a really big indicator of how fast this is moving and how important real-time data must be for these guys to be making such big investments to be able to do their analytics, right, the data, and even move some of that to the cloud. Related to this, again, you're here obviously at this conference because you believe data is super important. I was at the keynote this morning around data and oil and the similarities and differences, which I thought was fantastic. I think what we're also seeing is how that real-time element of data is growing. And so if you haven't been looking into it, one of the projections, which actually is old, I was looking for a new one, but one of the last projections from IDC is that real-time data is going to be 30% of the data sphere, as they call it. So I don't know how many of you look at or purchase the IDC report, but it's very interesting, and I haven't seen an update, but I would venture that that number 30 is probably underestimating the amount of the data universe that is considered real-time data and how much more it's being used. So, and what we see is the reason why it's being used is, on the one hand, so much of it's being created. The Wayfair example was a perfect intro because all of that is real-time data. Clickstream data, all of the behavior that they're trying to use is real-time data. So how quickly can you use that data, gather insights, and operationalize it, whether you're giving it to someone, a data scientist, or you're feeding the insight right into a business process. And it's touchless, basically. Financial sector is a really good example where, for example, trading, post-trade analytics, or even trading analytics in order to make the trade. But what we see is insights-driven businesses simply perform better. They perform better than other businesses. So that's another reason why it's so important. The other big trend we're seeing, which helps make the case, is that the window of opportunity in which to make these decisions is getting smaller and smaller. So there's this narrowing window, and that's where you see a lot of differentiation between companies that can drive to that level. And it's really interesting. We did a research report about a year ago. We launched it. You can find all this on our site, called the Microsecond Mindset. And we did that in around February of 2021, and the percent of respondents that said that real time was I think a millisecond or less was 13%. And we just did a new report with an external organization, actually, a research organization, and that number's already doubled to 25%, right? So that is a millisecond or less. Right, so super small amounts of time. Already there's double the respondents that believe that that's really what real time is. Now, of course, it depends on your business. We do see companies and industries where real time is a minute, which for some companies is eternity, is really long. And we see some that's even longer. But what you find is that's making a big difference in the ability for the company to differentiate itself. And that's either to fight off competitive impact or to be the disruptor in their industry, is how quickly that they can go make that decision. And here you see the two angles. One is working with digital consumers, where they're constantly driving this real-time data, but also at the organizational level. And what was interesting was a tier 1 investment bank saying our next data warehouse, this was a quote, by the way, we couldn't name them, but this is a customer quote during a conversation saying that our next data warehouse will not be a data warehouse. The new frontier for deriving unique business value from data is moving from seconds to milliseconds. So was just a very interesting quote where, you know, we're saying this is a market-driven dynamic. Another important trend in all of this new frontier around real-time data analytics is how important the cloud is becoming. And I think that was mentioned by Sudha in the prior presentation. And what we're seeing is that when we say cloud, it's not just a destination, and many of us think of it as a place, right? What cloud are you putting your data in? But actually, more and more customer conversations, what they mean is cloud as a way of working, right? And what we mean is you can do things very seamlessly when you're trying to get scale, right? When you're trying to use enormous volumes of data, high velocity, the storage benefits, the scale benefits, the flexibility. And there was another interesting anecdote here, which is using the cloud application developers being able to come up with an idea on a Monday and basically have it up and running on a Friday in a prototype. That kind of speed, innovation, and agility is really what is enabled by the cloud. But that doesn't necessarily have to be a public hyperscale cloud. That could be a hybrid environment, but it's also that flexibility, that flexible way of working. For many of you in the room, I'm going to ask another show of hands, because here I have, what about the edge? How many are in, non-financial sector? Right, yeah, most. So another interesting trend is around the edge, and I thought this was, fascinating. I know maybe many of you follow Gartner as well. We work with them, and this relatively recent report on trends in data and analytics is by 2025, not too far off, that more than half of enterprise critical data will be created and processed outside the data center or the cloud, and more is happening at the edge. And I think the key in the conversations we're having with our customers that are really, I'll be honest, operating at that frontier, right, especially in the financial space, where they're talking under a millisecond, in many cases even microseconds, that this is so important for them to be able to now figure out in the industry sectors how to do that kind of computing right at the edge. And so these are some of the things to be looking at as well. Do you really need to have all the data come back? What kind of an architecture is best to get the analytics done where it's most efficient to do it? And also where the insight is going to make the difference, where you're then driving the decision. Because it's not just for the sake of the insight, but it's for the business value, the result that you're trying to drive with that information. So these are some key trends that we wanted to share with the audience today. And hopefully many of you are already looking into it. In fact, I'd love to see that show of hands as well. How many of you came here wanting to learn more or are interested in real-time, or your businesses are starting to dip their toe into real-time data analytics? Yeah, many of them in the retail space. Those are typical use cases. So this is, oops, I'm going to go back one. So what we're seeing is real-time data helping to unlock new potential. Oh, it does not want to stay there. No, there we go. Oh my goodness, that's funny. Okay, well, thankfully I'll remember it. So it's powering a lot of different use cases, and it's across various industries. The obvious one was the finance. In fact, for us at KX, that's where we really cut our teeth, was in some of the hardest and most demanding use cases that have to do with data and driving decisions pretty much immediately. Other ones are in the industry space, where some of you, I know, have raised your hand that you're working. But very interesting use cases there when it comes to some of the operational processes and how to use data in order to, whether it's improve yield, increase productivity. There's a lot of work now on the OEE. That's an interesting one. There's some companies that are looking at point solutions or having an application there. We were just having an internal discussion about this the other day, versus looking at your data platform, right, as a place where you can go perform that function or work on that problem as well as other problems. And we think in the industry sector that there's a lot of horizontal cases, right, data problems that can use a horizontal software. And that's where we're starting to see KX get pulled in to help solve some of those problems. But these are very common no matter what the industry is. We also see it in utilities. Telecoms has been an interesting one as more and more move to software-defined networks, and you have so many sensors everywhere, not just in manufacturing plants, but on utilities as well, using that information. So that information coming in at speed and being able to generate insights and then feed that back in. In the prior example, the ad bidding was a very good example of use case for real-time analytics. When you think about how quickly a lot of these companies like Wayfair are serving up either an ad or recommendations as you're making your purchase. So those are some of the examples as well. So I'll just leave you with just some basic insight on KX. I'm going to skip this one. And it's all about the outcomes. So these are just some examples. But what I'd love is to just encourage you to learn more around real-time analytics analytics and the value that it can bring to some of the work you're doing now, and how you can marry it even with your historic data. And come by and we can chat more. Obviously, we've got some of our folks at the booth that can answer any questions you have. And we also have some research that's available. So if there are any questions, happy to take them, or we can have Sudha come back on and you can ask both of us.
Any questions?
Sure.
Typically, because I'm looking up here, the types of data that's, like, kind of understands, like, hey, we don't want to just have, like, streaming data just to have streaming data, you know, like live data. So, like,
Yeah.
is there, like, is it all around financial right now? Like I see betting is one I thought about.
Yeah.
Really, like,
Yeah, not at all. That's a really good point. And so there's quite a few use cases in industrial production, what we call discrete manufacturing, where they're making one particular item. So whether it is, well, automotive is another one, but, bottles, liquids, medical devices, absolutely. The more and more all of that smart manufacturing, smart factory, that sensor data that's coming in real time, again, depends on the business. If the business wants to go to that microsecond level, they're going to need that power. It doesn't have to be. But the key is, and what makes the traditional data infrastructures just not good enough for those problems is, you have enormous amount of historic data sitting in all these disparate places. Now you have a stream of data coming off of devices in real time, and you want to use that to enrich the data that you have. Bring that together. And that is definitely happening in industry and in transportation as well. I know we had chatted earlier, and we had an interesting demo that we actually used for Forrester when we were sharing with them some information, and it was trucks, and we were showing them a visual of the trucks in Australia actually moving in real time, gathering all this different data from sensors all around these shipping trucks, and doing things like sending signals to the driver to tell them certain pieces of information that they needed to know. So it does go beyond financial sector, although that's probably the sector that first broke into it.
I think you're talking about the time travel, right? So what is the window of time? So it is by default, it is 7 days, but you can also configure it if you want more or less.
No, I mean in terms of data which goes as far back as a year or two, we would want to have, some kind of information like the average number of clicks that existed a year ago or 2 years ago, and compare that with the more
Yeah.
recent data. So do you also keep historical data?
So we do have historic data. I think for the last 7 to 8 years, we have the historic data. And to your question, I think the better way would be to, whatever is the use case, we can actually aggregate and process that data and maybe find out the aggregate number of clicks for that year, and then save that in a smaller table, and then get rid of the data if we want to, because we cannot just keep holding on to a lot of data, right? So at some point we'll have to prune it, and when we are pruning it, we can always aggregate it and then get rid of the granular data.
All within BigQuery?
Yeah, everything in BigQuery, yeah.
Okay, well, thank you to both of our speakers, Sudha and Kathy. Thank you very much. Thank you.